Hi, welcome to the session on Singapore's nationwide COVID-19 response with AWS Serverless. My name is Tong Seng, and I'm a solutions architect here at Amazon Web Services. In my role, I have the privilege to work with innovative customers such as the Government Technology Agency of Singapore, who we are glad to join us today for this session. William Jiang and Alex Ng, who are software engineers from the Government Digital Services Division in GovTech, will be co-presenting this session with me. At AWS, we emphasize heavily on getting customers' feedback and working backwards from them. And our customers are telling us that in order to be successful, be it in their business or in their mission, what they really need are four simple things. Our customers want teams to move fast, to experiment, innovate, and bring concepts to market quicker than ever. They want their applications and systems to be highly performant, reliable, and scalable. At the same time, great performance should not compromise on security, ensuring that their data is securely protected and isolated. Finally, they want to achieve all this while constantly seeking to lower their costs of ownership. With that, we see many customers turning to a serverless-first strategy to achieve this success. A serverless-first strategy enables our customers to focus on things that truly matter to them and their customers. In fact, serverless adoption at AWS is growing at a tremendous pace. Since the launch of the first ever serverless service in 2014, AWS Lambda, we have hundreds of thousands of customers building serverless applications that drive trillions of invokes per month. In other words, serverless is a proven technology with widespread mainstream adoption. And how serverless is able to do that is really down to four main defining characteristics. Running serverlessly means having no servers to manage, as AWS takes care of the undifferentiated heavy lifting of infrastructure management activities such as patching, maintenance, and operations for our customers. Customers only need to focus on writing code, defining their business logic, and innovating and experimenting for their end customers. Serverless services scale automatically with usage, and whether you are serving a single user or a million, you do not need to sacrifice on performance. While being able to scale massively and quickly is great, you also don't want to end up with a huge amount of unused or waste resources. This works well with serverless because you never pay for any idle resources. AWS Serverless services have built-in fault tolerance and security, relying on highly available and redundant global infrastructure of the AWS regions and availability zones, which are secure and certified against many global industry compliance frameworks and standards. We hear a lot from customers building great applications and delivering meaningful business outcomes and user experiences. At the same time, benefits of moving fast, scale massively, and securely actually matters even more when dealing with national emergency situations. We see customers, especially our public sector customers, leveraging these capabilities to deliver on national mission-critical workloads in the most trying of times. And with that, I would like to hand over the time to my guests from the Government Technology Agency of Singapore, who will share about their journey using AWS Serverless to develop TraceTogether and SafeEntry, two applications which played a crucial role in Singapore's COVID-19 response.
Hi, my name is William, and I'm very excited to share how GovTech has built impactful and meaningful products with serverless to address the COVID-19 pandemic. Let's start off with an introduction. The Government Technology Agency of Singapore, otherwise known as GovTech, is an agency within the Singapore government. Our mission is to drive digital transformation within the public sector in order to improve the everyday lives of people in Singapore. And there were many opportunities to improve lives when COVID first struck. In the early days of the pandemic, it quickly became apparent that there were two key limitations to manual contact tracing. One, it relied on the individual's ability to recall where they went and who they came into contact with, which leads to incomplete and inaccurate data collection. Two, it was simply not feasible to scale manual contact tracing. TraceTogether and SafeEntry were thus built to address these limitations in contact tracing. So, What is TraceTogether or SafeEntry? Let's do a quick primer. TraceTogether is a community-driven, Bluetooth-based contact tracing app that determines risk of infection through proximity. When TraceTogether users come into close proximity with each other, temporary identifiers are exchanged through Bluetooth connections and stored on the phone. Upon testing positive, the affected user will be notified to upload these TemIDs, which are then processed into meaningful data that can be used in the contact tracing process. On the other hand, SafeEntry is a national check-in system that determines risk of infection through location. The data collected is used to track and isolate confirmed clusters at places with high human footfall, such as malls. Check-ins can be done either through QR code or via Bluetooth connection with a SafeEntry device. At this point, it must be emphasized that TraceTogether and SafeEntry are built as distinct and separate systems with no shared data stores. Only the Ministry of Health has access to the full complement of data collected by both services to conduct contact tracing. With both of these services in place, we have managed to reduce the time taken to quarantine possible infected cases from 4 to 5 days to just 1 day, which slowed down the spread of the virus. Furthermore, the data gathered allowed the Ministry of Health to better detect and respond to large COVID-19 clusters, like the one at Jurong Fishery Port and Changi Jewel. The early days were fraught with teething problems. For one, the original teams were formed with volunteers from different product teams across GovTech. Next, there were no existing tools or products we could iterate or build on. Also, at that point of time, it was a race against time to build a product and to build it well. And back then, nobody could foresee the pandemic lasting for over 2 years. So, if we move too slowly, we risk launching the product right as the pandemic blew over, which defeats the purpose of having a product in the first place. The last challenge was finding a very reliable platform to build on. High reliability ensures little to no loss of contact tracing data. But more importantly, because we were launching products that were the first of its kind, we needed to build trust. We had to show the government that they could rely on our services to enhance contact tracing efforts. And we had to show the public that our services worked well. Lastly, our services required a higher degree of agility in order to handle the ever-evolving requirements from the Ministry of Health. These challenges led us to serverless technologies, and the benefits really addressed our pain points. Serverless promises fast deployments, inherent scalability, availability, and reliability. It was highly customizable and extensible, and had inbuilt security features that we could tap into. With no infrastructure management required, it meant that the product teams could focus on the important thing, driving product goals. So, the decision was made to use serverless. Here are some of the services we use across both platforms. Now, let's take a deeper look at how we have tapped into these benefits to build both TraceTogether and SafeEntry. Speed to deploy and ease of deployment ranks high as one of our favorite points about serverless. Using Lambdas, for example, all you need to do is to write code in the handler interface, specify the deploy configurations in the YAML file, and run the serverless deploy command, and you'll have a working instance ready to go. Fast deployments lead to faster feature releases and even faster bug fixes. As a matter of fact, on average, the entire TraceTogether codebase takes just 13 minutes to deploy to production. Inherent scalability without the need for manual intervention is another strong point. And this is important in the context of TraceTogether because it allowed us to keep costs low when we're still iterating on the product, serving a user base in the thousands. When the user base grew to 5.6 million, serverless kept the system performant without us having to worry once about scalability issues. In fact, serverless scaled so well that on occasions, we unintentionally DDoSed downstream services during the second and third waves of COVID infections because of increased load. With serverless, the question shifts from how much can we scale to how much concurrency can we support. To demonstrate the scale we're working with, let me use one of our higher traffic workflows. It's a very simple, almost classical use of Lambdas and DynamoDB. On the right, we have a persist TemIDs Lambda that writes temp IDs to user identifier mappings to a DynamoDB table. Downstream, we have two lambdas that query this table to resolve temp IDs into user identifiers. At its peak, this workflow can handle 10,000 writes per second and 3,000 reads per second with no loss in performance. Because of its high availability and reliability, we found serverless fit for our mission-critical workloads. Besides the high uptime guarantees, serverless has automatic retries in case of failure. For example, if my API call to DynamoDB fails because of some internal error, serverless retries my request for me and only throws an error after a threshold for retry has been exceeded. On the right, you'll see the diagrams of two of our core business workflows running entirely on serverless. At this point of time, I would like to take the chance to bring up a case study that really demonstrates how all these benefits came together for us. The workflow you see here is an integration between the TraceTogether and SafeEntry teams. In a nutshell, this integration allows TraceTogether users to check into locations with their phones via Bluetooth with a SafeEntry device. A temp ID is exchanged and passed on in a HTTP request through an API gateway set up by TraceTogether. The API gateway is integrated with the lookup lambda that validates the temp ID and attempts to resolve it into a user identifier before returning the data as a response to SafeEntry. SafeEntry will time out the request if it exceeds 5 seconds. Aside from reducing friction of the QR check-ins, this integration also enabled enforcers to ensure only vaccinated or exempted individuals could enter public places. Once again, the considerations apply. No such integration existed initially because TraceTogether and SafeEntry are separate systems, and we were under a very tight timeline to get this up in production. We built and deployed the pipeline to production in under 2 weeks. Now, it serves 2 million requests a day, with requests peaking at around 50 requests per second during peak hours. 99% of all responses are served within 170 milliseconds, which falls well below the timeout limit set by SafeEntry. Furthermore, being on serverless allowed us to quickly tap into services like WAF and the inbuilt throttling to protect our API gateway. We were also able to very easily build dashboards to monitor key performance metrics provided by CloudWatch. All this was achieved without worrying once about infrastructure. With that, let me pass my time to Alex, who will elaborate on how SafeEntry leveraged on serverless.
Thanks, William. So William shared pretty extensively about serverless in terms of API gateway, Lambda, and DynamoDB. Let me now share with you a little more on another flavor of serverless, serverless containers, which is our main service of choice for SafeEntry. When we first got the call to deliver SafeEntry, volunteers from many different product teams came together to form the SafeEntry team. There was an urgent need for people to go out for necessities and to do it safely. So for us, it wasn't so much of choosing between different cloud service providers, but more of choosing to work with what we were familiar with in order to move fast, really fast. With this new volunteer team back then, we were mostly familiar with Ruby on Rails and using typical jQuery JavaScript frontends. So as you can now see, we were familiar with monolithic applications running off containers. And we also have folks who have experience working with AWS services. Hence, the decision to go with ECS Fargate was pretty straightforward. It takes care of all the orchestration, health check, and auto-scaling. Most importantly, it allowed the team to work with what we were already familiar with. With ECS Fargate, we could quickly deploy and scale during the early mad rush, and we could spend more effort focusing on code, focusing on functionality. Earlier, William shared about the TraceTogether SafeEntry lookup API integration and how we were able to build and deploy that quickly. To share a little more insight, the API that resides in TraceTogether right now was actually co-developed with SafeEntry engineers back then. We had tons of feature requests and a lack of manpower to deliver them as quickly as we intended to. However, because both TraceTogether and SafeEntry are on AWS, and we are already using a bunch of serverless services, the skills are transferable. And this allowed the team to focus on building the API's functionality and greatly enhance both teams' ability to co-develop. So back then, we delivered our MVP within 3 days. We first got the brief on a Sunday night, and we were down at the major wet markets, scanning visitors' ID card barcodes, doing testing by Wednesday in that same week. And today, we're serving around 600 transactions per second during peak hours. And now that we have seen how both teams moved fast to respond to urgent needs, I'd like to also highlight that all these weren't achieved at the expense of security. Typically, when delivering technical products in the public sector, there are certain things that we need to do before a product release. These things include a vulnerability assessment and penetration testing, and working through threat risk assessment and analysis with our security folks. There are also quarterly vulnerability assessments that we have to perform. These, of course, vary for different products of different nature. So in the early days, we were able to fast-track some of these requirements as a result of our choices of services. We use a bunch of serverless and managed services, which complies to various certifications and standards. There's throttling provided for us. We could implement anomaly detection, and it was very easy to debug and support operations. I'll now go through each of these points in a little more detail. When we talk about serverless and managed services, we need to understand that there is a shared security responsibility. We offloaded parts, not all, of our security efforts to AWS. And with serverless, AWS takes care of more responsibility areas than the typical shared responsibility model for services like EC2. AWS deals with the infrastructure, while we deal with the rest. And this has saved us a lot of time and allowed us to move fast. And these services on AWS, they already have a whole suite of different certifications and compliance to standards, all the more increasing our confidence in what we're running. And then there's throttling. When we use a combination of API Gateway, Lambda, and SQS, we're leveraging throttling, which is an inherent feature. This protection helps us avoid nasty situations where we end up consuming all of our backend's capacity. Also, with SQS, we leverage on asynchronous processing, where we can choose to perform manual intervention, to pause, or to resume queue processing whenever required. This has helped us in multiple situations when there were unforeseen issues like load spikes, and we needed time to investigate. The ability to pause such processing prevents us from continuing to overburden the system and gives us more of a runway to investigate. We also took a step further to raise the quality of contact tracing data using something we call anomaly detection, also as a form of a security control. This is achieved through the use of CloudWatch and its subscription filters. We push the unidentifiable logs into Elasticsearch, which gives us the capability to automate quick data queries. This way, we are able to throw in our logic to identify anomalous location patterns and notify the team via a Slack webhook for further investigation. And finally, we have a very important, if not the most important aspect, which is debugging and supporting operations. We used to run EC2 instances with SSH and complete all the chores that come with this approach in order to access our Rails console. With ECS exec, there's no more need for us to maintain these EC2 instances to achieve the same results. We now have the ability to go into our Rails console to perform debugging and support our daily operations securely. Also, it is pretty straightforward to set up, it is simple to use, and best of all, it is auditable. So whatever action we perform with via ECS exec, there is an audit trail for it, and this helps us in our compliance with our organization's policies. So I hope what I've covered so far gave you a better idea as to how we made use of the different AWS services to improve our security posture, how we did not neglect security, and how all these in turn allowed us to move fast. We still put in place security controls, we adopted secure coding practices, and these gave the stakeholders and ourselves the confidence to go live and release feature under tight time constraints. Now, before I let Thong Seng close off the last part of this sharing, let us look at what is coming up for TraceTogether and SafeEntry. In general, we're looking to support any upcoming measures that the Ministry of Health or the government may put in place. We're also looking to continue using our learnings throughout this entire period to keep modernizing product development to innovate. We have seen how ops, policy, and tech come together, aligning to a common vision, with none being just an afterthought. And we would like that to be the way going forward. Ultimately, we're still looking at using tech for public good, to leverage on the prowess of technology for the betterment of citizens' lives. And as we look to innovate and solve problems, it really doesn't matter what kind of technology we use. It is about how we use them. We do what we need, and we use what we need to get things done the right way. Back to you, Thong Seng.
Thanks, Alex and William, for the wonderful sharing. At Amazon, we know we are big and have a large impact on the world. We believe that given our scale and our capabilities, we can be a tremendous force for good. Through our services, technological expertise, and scale, AWS is uniquely positioned to support communities and customers around the world to address some of the world's toughest challenges, from natural disasters to health outbreaks to rights and equity challenges. Our global social impact team is focused on 3 pillars. 1, disaster preparedness and response. We apply our cloud computing expertise, services, volunteers, and resources to help organizations globally prepare for and respond to natural disasters. 2, rights and equity. We work to advance human rights and promote economic opportunities for marginalized communities. 3, global public health. We focus on supporting innovation and technology solutions to mitigate health outbreaks and tackle health and health equity challenges. In support of these pillars, we lead on several enabling functions. Our open data work operates under the principle that sharing cloud-optimized data on AWS accelerates innovation by reducing the cost and effort of data access, allowing data users to spend more time on research and product development. Our solutions team focuses on developing operational prototypes and solutions using cutting-edge technologies that disrupt the business-as-usual thinking of organizations within the social impact space. Through our programs including the 20 million AWS Diagnostic Development Initiative, the 40 million AWS Health Equity Initiative, the Open Data Sponsorship Program, and Project Resilience, we have built up COVID-19 diagnostic testing capacity and diagnostic innovation. We are supporting the creation of meaningful job pathways for formerly incarcerated individuals, lowered the cost and time needed for COVID-19 diagnosis, and helped combat drought in Tanzania, to name just a few. If you are an organization working to tackle a problem in the social impact space and believe we can help you accelerate your work through AWS's technology, solutions, and expertise, please reach out to us. Thank you for attending this session. We encourage you to get engaged with our training and certification content today. Skill Builder is our online learning center that makes it easier for anyone, from beginners to experienced professional, to build AWS cloud skills. We offer 500 plus free digital courses that can help you and your team build new cloud skills and learn about the latest services when and where it's convenient, in up to 16 languages. Within Skill Builder, take advantage of flexible learning plans, which offer suggested digital courses aligned to a specific domain or job role. As you build your skills, consider preparing for one of our 11 AWS certifications. These industry-recognized certifications span foundational, professional, and specialty levels to validate AWS knowledge and skills, building your credibility and confidence. We invite you to join the AWS Certified community, which brings together AWS certified practitioners and builders in an exclusive online community. You will participate in discussion forums, learning and networking opportunities, and challenges from AWS team to earn rewards and recognition. Scan one or both of the QR codes on the screen to get started with your cloud skills, training, and certification. Thank you again for attending, and we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take the time to fill out our survey and let us know what you think.